learners, I welcome you all to the fifth module on electrical measurement instrument of the online course on electricity and electrical wiring. This module consists of 3 sessions. In the first session, we have discussed about multimeter and other related electrical measuring instruments. In this session, we are going to discuss about 2 important instruments, namely the electronic voltmeter and the electronic ammeter. In today's topic, we will focus on the following topics: electronic voltmeter, next the block diagram of electronic voltmeter, which will be followed by the principle of operation of electronic voltmeter. Then we will discuss about the types of electronic voltmeter, then the extension of range of measurement of electronic voltmeter. Next, we will discuss about the electronic ammeter, which will be followed by the block diagram of electronic ammeter, then the principle of operation of electronic ammeter, to be followed by types of electronic ammeter, and finally the extension of range of measurement of electronic ammeter. The learning objectives are to study about the electronic voltmeter and the electronic ammeter, to understand the block diagram of the 2 instruments, to understand the operation principle of the 2 instruments, to familiarize with the different types of the electronic voltmeter and the electronic ammeter, to get an idea of the extension of range of measurement of the 2 instruments. Now, what is an electronic voltmeter? Generally, a voltmeter is an instrument which is used to measure the electric potential difference between 2 points in an electric circuit and is usually connected in parallel. It has a high resistance so that it takes negligible current from the circuit. By using amplifiers, voltmeter can even measure tiny voltages of the order of microvolts or less. A voltmeter which uses an amplifier for increasing its sensitivity is known as the electronic voltmeter. It is used for measuring the voltages of both alternating current and direct current devices accurately because of the high input resistance. The electronic voltmeter has high input impedance, because of which it is able to detect the signals of very weak strength which a moving coil voltmeter is not able to detect. In circuit diagrams, a voltmeter is represented by the letter V in a circle with 2 emerging lines representing the 2 points of measurement, as can be seen in the figure. This is the block diagram of an electronic voltmeter. Now, let us discuss on the working of the electronic voltmeter. An electronic voltmeter always has an amplifier which amplifies the very small current taken by it during measurement. The amplified current is then measured by a conventional permanent magnet moving coil instrument, generally abbreviated as PMMC or D'Arsonval movement. This means that the voltmeter takes very small current from the circuit, but it amplifies the current to higher value so that the current can be measured by the conventional PMMC instrument. An electronic voltmeter thus is able to measure a voltage without affecting the value of the original voltage. Such a voltmeter has its own power supply, and so it does not need to take any significant current from the circuit under measurement. In all electronic voltmeters, the principle involved is that an indication on a PMMC proportional to the input voltage is obtained by means of amplification in 1 or more stages with large input impedance. The pointer is deflected by taking the supply from the amplifier circuit. The additional power does not pass through the deflector, because of which the meter provides an accurate reading. Now, let us study about the types of electronic voltmeter. There are 2 types of electronic voltmeter, which are the analog electronic voltmeter and the digital electronic voltmeter. Let us now understand what an analog electronic voltmeter is. A voltmeter whose output is obtained by the deflection of the pointer on the calibrated scale is known as an analog electronic voltmeter. It is a voltage measuring instrument which has high circuit impedance. Such a meter uses the electronic amplifier for controlling the input signals, and it is further classified into AC and DC analog electronic voltmeter. Digital electronic voltmeter. A voltmeter which provides digital output reading of the measured voltage is known as a digital electronic voltmeter. The output of such a voltmeter is in the form of a numerical value. Digital electronic instrument reduces both the human and the parallax error because the reading is directly shown in numerical form. The first digital voltmeter was invented and produced by Andrew Kay of Nonlinear Systems, and later he was the founder of Kay-Pro in the year 1954. An analog to digital converter, in short, also abbreviated as ADC or AD or A to D, is used to give the numerical value. ADC is a system which is used to convert an analog signal, such as a sound of a microphone or light entering a digital camera, into a digital signal. It can also provide an isolated measurement, such as an electronic device that converts an analog input voltage or current to a digital number representing the magnitude of the voltage or current. It converts a continuous time and continuous amplitude analog signal to a discrete time and discrete amplitude digital signal. Digital voltmeter measurement accuracy is affected by many factors like temperature, input impedance, and power supply voltage variations. Inexpensive digital voltmeters generally have input resistance of the order of 10 megaohm. Precision digital voltmeters can have input resistances of 1 gigaohm or higher for the lower voltage ranges of less than 20 volt. There are many advantages of electronic voltmeter, which are: number 1, detection of low-level signals. The electronic voltmeter uses the amplifier which prevents the load error and detects very small signals which produce the current of nearly 50 microampere. The detection of low-level signals is essential for determining the true value of the measurement. Number 2 is the low power consumption. The electronic voltmeter has vacuum tubes and a transistor which has the amplifying properties. It uses the auxiliary or the secondary source for the deflection of the pointer, and the voltage controls the deflection of the sensing element. Therefore, the circuit of the electronic voltmeter consumes very limited power. Number 3 is high frequency range. The working of the electronic voltmeter is free from frequency range because of the transistor. Along with the voltage, the signal of very high and low frequency can also be measured through it. The electronic voltmeter measures the power only when the circuit is closed. That is, the current flows through the meter. The next topic which we will now study is the extension of range of measurement of electronic voltmeter. Range extension of a measuring instrument is a technique by which we can increase its measuring capability to measure a much larger value than what it is actually designed for. As an example, we can consider an analog AC voltmeter which is built to measure from 0 to 20 volt AC voltage only. But we extend the range of this voltmeter to measure up to 230 volt AC voltage. This is known as range extension, which can be achieved by adding a high but desired amount of resistance in series with the voltmeter. Now we will study how to find the value of the desired resistance value required for range extension. If the actual measurable voltage represented as VA is equal to 20 volt and the voltmeter resistance RA equal to 5 ohm, then maximum current that will be allowed through the voltmeter by applying Ohm's law will be 4 ampere. Let the resistance to be connected in series be of R ohms, which will be calculated according to the required voltage to be measured, which here in this case is 230 volt, and the maximum current allowed through the instrument as represented by IA. The calculation is as shown here. If we connect R in series with the voltmeter, then we will have R plus RA equal to 230 divided by IA. On calculating, finally we will get the value of R equal to 52.5 ohms. Therefore, by connecting R of the above value in series with the 0 to 20 volt range voltmeter, we will be able to measure voltage up to 230 volt. Now next, we will discuss about the method to read the high voltage value from the low range voltmeter. Let us consider that the 20 volt voltmeter has 20 units from 0 to 20 and each unit reads 1 volt. Now, after range extension, 20 units are now capable of reading up to 230 volt. So 1 unit will read 230 divided by 20, which gives 11.5 volt. Now, by calculating the number of units and multiplying by 11.5 volt with the read units, we will get the actual voltage. Say the voltmeter reads 10 units, then voltage will be 10 multiplied by 11.5 volt, which is equal to 115 volt. Dear learners, let us do a self-check of our learning so far by attempting the following questions. Electronic emitter. What is an electronic emitter? An emitter, abbreviation of ampere meter, is a measuring instrument which is primarily used in different electrical circuits. Its basic purpose is to measure the electric current and to determine the intensity of the current. Electric current represents the speed of charged particles passing through a circuit and is typically measured in amperes. It has a low resistance. It is connected in series with the load to measure the electric current flowing through it. As the emitter has a very low resistance, therefore, when it is connected in series with any circuit, it does not change the current in the circuit. The emitter symbol is represented like this. This instrument is used to measure the current both AC and DC in the circuit. It is also used to measure the magnitude of the current flowing across the circuit. This is the block diagram of an electronic emitter. Next, we will study about the principle of operation of the emitter. The basic working principle of an emitter is that it must always have very low resistance and inductive reactance. Inductive reactance is the resistance offered by the inductive circuit. It is the opposition to a changing current flow offered by an inductor. The SI unit for it is ohm. The low impedance is necessary to minimize the voltage drop and the power loss. An ammeter is connected in series because the current remains the same in a series circuit, which ensures accurate measurement. Because of the low impedance, the power loss in an ammeter is very small. On the other hand, if an ammeter is connected in parallel, then it would create a short circuit causing all the current to flow through it, resulting in burnout of the instrument. Therefore, ammeters must always be connected in series. Ideally, an ammeter should have zero impedance for zero voltage drop and no power loss. But this is not practically possible. There are different types of electronic ammeters. On the basis of current passing through the instrument, there are two types of electronic ammeters, which are the direct current or DC ammeter and the alternating current or AC ammeter. This is the pictorial representation of a direct current ammeter. A direct current ammeter is an instrument which is used to measure the amount of direct current flowing in a circuit. The DC ammeter has a scale which represents current in ampere. This instrument is named as ammeter from ampere meter because it measures the amount of current in ampere. A DC ammeter has a resistance of 0.1 ohm and its current range is 0 to 100 ampere. If the range is to be extended to 0 to 500 ampere, then it must have shunt resistance. In direct current, the voltage is always constant and the electricity flows in a certain direction. This figure shows the alternating current ammeter. An alternating current ammeter is an instrument which is used to measure the alternating current flowing through the components of the electric circuit. Here, the voltage periodically changes from positive to negative and from negative to positive, and the direction of the current also periodically changes accordingly. Finally, let us discuss about extension of range of measurement of electronic ammeter. Shunt resistance is used for the range extension of an electronic ammeter. A shunt is a low value resistance having minimum temperature coefficient. It is connected in parallel with the ammeter whose range is to be extended. The combination is connected in series with the circuit whose current is to be measured. This helps in measuring the current with greater precision. The total resistance in the circuit decreases when more parallel resistances are added, as according to Ohm's law, the lower is the resistance in a circuit, the higher will be the current in it. Dear learners, as we have come to the end of the discussion on the electronic ammeter, let us test our learning by attempting the following questions. learners, in today's session, we have discussed about the electronic voltmeter and the ammeter. We have also learned about the range extension of a measuring instrument and have understood that it is a technique by which one can increase the measuring capability to measure a much larger value than what it is actually designed for. I hope the information given in this video will help you to enhance your knowledge about the electronic voltmeter and the ammeter. Thank you.